On C, they seem to be saying they know it's going to be first order. On the provided axes, graph a function of CV versus time that will provide you with a straight line. Well, obviously, they're checking to see if you realize that being first order, you should be plotting the natural log of crystal violet versus time. But I don't think that that's all they want. I think that the axis labels might be one thing, but I think they actually want us to plot it. Let's see what they've got down here. Well, this stuff looks like it's going to the next question. So I can't see any other way around it. I think they want us to actually make a column with the natural logs of these things. We would have a calculator during this part of the test, so let's try it. So there are my values when I natural logged these guys. So I just took natural log of 5.5 times 10 to the minus fifth, and I got negative 9.8, and so on and so forth. So now I've got to plot it. So my time, there is more emphasis this year on actually making graphs. So we want our time to go from 0 to 180. So, I mean, we could go all the way out to 200 if we wanted to, and we could call this one 100. This would be like 150. This would be 50. I think 50, 100, 150, 200, like that. The natural log one's kind of weird, you know, we don't normally plot it in this way, but remember, these axes do not always have to start at 0 on the origin, and we know that as it went down, it would become, so let's say the origin is way up here, you know, we'd have negative 1, negative 2 as we went down, so negative 1, negative 2, and so on and so forth. So I think we want to go from like negative 11 here, up to about negative 9 there. So let's try to plot it like that. So let's say negative 11, and then negative 9. This would be negative 10. So let's start plotting our data. I'm going to do the first one, and then we can, you know, kind of skip it from there. So the first data point is 0. Whoops, that's not good. The first data point is 0 and negative 9.08. So 0 time is right here, and negative 9.08 would be like right about there, somewhere in there. And then 60, anyway, I'm going to go on from there. Alright, so there we go. I think I plotted them all. And, you know, they want a straight line graph, so it may be best if we did this. We would not have a ruler on the day we were doing it, but I think that's it. Make sure that you got your axis labeled and your numerical label, since you're having to choose it. Alright, so we're on to part D. They want us to write the rate law for the reaction. Well, we know that rate is going to equal K times the concentration of the two reactants. And I have the reaction down here, so CV plus and OH minus. Now, of course, the question is, what are the orders? And for that, they give us a rates data table here. They change the concentrations. We just have to figure out how they're going to work out. So let's do OH first. Let's see. OH looks like it's doubling right there. And from there to there, it looks like it's doubling as well. So for OH, if we compare experiments 1 and 2, then 2 to the x equals 2, and we're going to label this as the change in concentration of OH, and that is the change in rate. And so x equals 1, and that is the order for hydroxide. So we can put that up there now. That's a 1. Well, that's not very neat. Oh well, it's not going to fix. Okay, and then we've got to do the second one. Okay, so the second part is a little bit tricky. You notice if we go to look for a comparison to find the order for crystal violet, there's change here, but there's no data here. There's change there, but there's no data. And we can't do 1 and 2 because there's no change. But of course up here they told us it was first order with respect to crystal violet. So we know that this is 1, and now we know that this is 1. So I think that's our answer to part D. Let's look at part E. Now since we know the rate law we can plug in any experimental data to find K. So I'm going to do all the data from 1. So I get 0.055, 2 sig figs, because that had 2, that had 2, and that had more than 2. And then we just got to figure out the units. So the units up here I've drawn down over here, so rate is always molarity per second, and you can see the rest of it set up. I'm going to have to divide both sides by those 2 molarities, and one of them will cancel, and my units for K are going to be 1 over molarity per second. And there we go. And then lastly F, since we know our rate law and we know K, we can determine the initial rate of formation of this stuff in this spot, which is what they're looking for, just by plugging in the values. So here we go, we have our rate constant K, our concentrations, and they're to the first order, and so our rate is going to be 4.0 times 10 to the minus 7th. I'm going with 2 sig figs because that's what our prior answers seem to have. And check for reasonableness. You know, it's a little bit slower than the rate of the one before it, but the concentration of that one went down, so it seems like it's a reasonable rate.